Let's look at number 4. We have x squared plus 5x is less than or equal to 0. Less than or equal to 0. So let's go ahead and factor this. We're going to have x, just pulling an x out there, and an x plus 5 is less than or equal to 0. Okay, so the real zeros, not the fake ones, are going to be 0 and negative 5, right? That's what makes this side 0. Plug 0 in, 0 times the number is 0, and plug negative 5 in, negative 5 plus 5 is 0. So we set both these factors equal to 0. And I'm kind of skipping that step, hoping that you know that. So there's some intermediate steps that I'm not really taking. Okay, assuming that you already know those intermediate steps. So let's go ahead and we'll put negative 5 right here, and we'll put 0 right there. Okay, and that's now pick some test points. How about negative 6? And what about negative 1? That's a good one. And 1. Okay, some easy ones there. Alright, so let's take a look at this. Negative 6, if we plug this in up here, we get a negative number, right? And then negative 6 plus 5 is a negative number, and a negative times a negative is a positive, right? And let's see, let's take a look at negative 1. So this is going to be negative 1 times, and then this will be negative 1 plus 5, which is 4, and a negative times a positive is negative. See that? And then let's go with 1. So that's obviously going to be 1 times 6, so that's a positive times positive is a positive. Now looking at this inequality here, this number must be less than or equal to 0. Now you see this right here, equal to means we can include these guys right here, okay? And it must be less than 0, so it must be a negative. So we're looking at, I guess I didn't do this on the last problem, but we're going to include, there's a couple ways of doing this. You can use brackets or a filled in circle, either way. Alright, so we're going to be including negative 5 and 0. So we're going to write this now in interval notation. Right, negative 5 and 0. And of course, if you wanted to write this in inequality notation, it would be x is greater than negative 5 and less than 0. See a mistake here? Yep, got to put that in there, right there, okay? Because that means x is greater than or equal to negative 5, or x is less than or equal to 0. Alright? Okay, you are coming right along with this stuff. Alright, and that was number, what was that? That was number 4, so this looks like number 5 here. Number 5. Okay, so we have x squared is less than or equal to 9. Now there's a couple ways of doing this. Remember that square root property where we could square root both sides and then just say plus or minus? Okay, we could do that, or we could do it like we've been doing it, which that's the way I'm going to do it. And just get this thing in the standard form. Bring everything over here to the left. We factor this. This becomes x minus, whoops, x minus 3 times x plus 3. Right. Okay, so we'll want to find our real zeros, and that's just going to be 3 and negative 3. Okay, so those are the real zeros there. Not the fake zeros, but the real ones. Alright, let's draw a number line. Let's plot our real zeros on here. So we have negative 3 and positive 3. And now what we'll do is some test points. And let's just pick negative 4. Always pick 0. That's always an easy one. And then we'll pick, 4 here. Right, pick 4. Okay. Alright, so let's go ahead and plug these test points in and see if it's positive or negative. So we plug negative 4 in. We get a negative number, right? Because negative 4 minus 3 is a negative 7. So I'm not doing the math on that. I'm just saying, is this negative or positive? So plug negative 4 in, you get a negative number, negative 4. You get a negative number, right? And a negative times a negative is a positive. Now let's take 0. That's going to be 0 minus 3, so that's going to be negative. 0 plus 3 is a positive, and a negative times a positive is a negative. Now we plug 4 in, that's going to be positive. That'll be positive, so that should be positive. Alright. Okay, well, let's take a look at this now. This says less than or equal to 0, so we're going to include these points here. Right? And this number must be, okay, is less than or equal to 0 means it's got to be a negative number. So we look inside this interval here. This is the interval we're going to be looking inside right here. As you can see, these would be all the negative numbers, including the endpoints for that. So we write that in interval notation from negative 3 to 3. Alright, and of course you can write that in inequality notation. X is greater than negative 3, greater than or equal to negative 3, and x is less than or equal to 3. Alright. Okay. Let's see. Oh, now we're going to something a little bit more difficult. Gotta throw a little twist in here. So we have this rational number, x minus 2. Remember, the title was polynomial. Polynomial, that's what we just got to doing in rational inequalities. So we have x minus 2 over x plus 4. And that is less than or equal to 0. Less than or equal to 0. So what we're going to do is first start off with the x minus 2, right? Set that equal to 0, so the real zeros of that is going to be 2, right? Plug 2 in, you get 2 minus 2 is 0. And then we'll look at x plus 4. And set that equal to 0, solve for x, so that's going to be a negative 4. So the real zeros are 2 and negative 4. See that 2 and negative 4, that's our the real zeros. Yeah. Alright, well, just like we did in the previous problem with just the polynomial, we're going to do our graph, and we're going to plot our zeros, negative 4, and 2. Now there's something that you need to keep in mind here. Alright, we can't use negative 4 if it's in the denominator here, and the reason for that is because you can't divide by 0. So one thing we know about negative 4, we can't use it. So I'm just going to go ahead and put an open circle right here. Right, and we're going to work several of these problems so you'll understand what's going on that. Right. So let's go ahead and choose our test points now. So we have negative 5. Of course, we always use 0 if we can. And we'll use 3. Okay. Alright, so here we go. So you take negative 5, you plug it in up here at the top. So that's going to end up being a negative number. And you know what? We're going to just write this down here. So negative 5. Plugging negative 5 in up here in the numerator, you get what? Negative 7, so it's a negative number. And then plugging negative 5 down here in the denominator, that's a negative, and so we end up with a negative over a negative is a positive. Okay, and we'll go ahead and write that right there. Alright. Okay, so let's go ahead now and take a look at 0. So plugging 0 in, you get a negative in the numerator. Plug 0 in, you get a positive. So that's negative over positive, and a negative number over a positive number is just a negative number. And then now we go ahead and look at 3. So we get a positive over a positive, and that would be, so positive over positive, and that's going to give us a positive number. A positive number divided by a positive number, you get a positive number. And I guess I should have been writing this up here. Alright, so now we can take a look at this. Now remember, we can't use -4. Okay, so we got to keep that in mind. Now this number right here must be less than or equal to 0, which means it must be negative, a negative number, and it can equal 0. Okay, it can equal 0, but it must be negative. So let's take a look at this. So between -4 and 2, this is where all the negative numbers, right, all the numbers for our solution. We can't use -4, but we can use 2, but it can include 2 because that will give us 0 here, and 0 over a number is 0. 0 over a number other than 0, right, is actually equal to 0. Okay, so we'll go ahead and write that. So between -4 and 2, and of course we include 2 here. Right. Okay, that wasn't too bad. Looks like I've run out of room. Okay, what are we doing now? Oh, we're going to continue to do those problems, it looks like.